for Lesson 8 is quadratic functions. So, scan the lesson, predict 2 things that you will learn about quadratic functions. Alright, so those are some of the things that we're going to talk about today. So let's take a look at our vocabulary startup. Here it says, in previous lessons you learned about nonlinear functions. A special type of nonlinear function is the quadratic function. Now a quadratic function, and this you should write in your spiral, is a function in which the greatest power of the variable is 2. So that means it's squared. So the variable, the biggest exponent is going to be a 2. So it's going to be an x squared or a t squared or an n squared, okay? Okay, so the greatest power of the variable is 2. That means it's going to be an x squared or a t squared or something like that, okay? Its graph is U-shaped, opening upward or downward, okay? The graph is one that looks like that. This one opens upward, or it's going to look like that. If you see it on a coordinate grid, it's going to look like this. Okay, that's what it looks like on a coordinate grid. Or, of course, it will look like that. Okay? So, that's the exponent. The quadratic function. Now, it says, what is the height of the ball after 1.5 seconds? What are we going to do with that? All right, so we are going to substitute for t. Okay? So we substitute it in. So we have h is equal to negative 16 times 1.5 squared plus 40 times 1.5 plus 2. So when we simplify the next step, order of operations says that I have to do my exponents first, right? So we're going to do 1.5 squared first. So we've got 1.5 squared, that's 2.25. So this is equal to negative 16 times 2.25 plus, can I go ahead and do this 40 times 1.5 now? Yep, we can. So we've got 40 times 1.5, that gives me 60, plus 2. Oops, I forgot my close parentheses right there. So now we continue. So 2.25 times a negative 16 is going to be what? Positive or negative? Positive times a negative is a negative. So this is going to be a negative 36 plus 60 plus 2. So negative 36 plus 60 is 24 plus 2. And my final answer is 26. 26 what? Look at the problem again. 26 feet. 26 feet. Because again, it says, what is the height of the ball after 1.5 seconds? So my units is feet. All right, a quadratic function. Quadratic function can be written in the form y is equal to ax squared plus bx plus c. And I do want you to write that down. Where a is not equal to 0. A cannot be equal to 0. It can be a positive, it can be a negative, but a, this first number here, cannot be equal to 0. Okay? The graph of a quadratic function is called a parabola. The graph of a quadratic function is called a parabola. P-A-R-A-B-O-L-A. parabola. And remember we talked about at the beginning, it either opens upward or downward, right? Well, here's something more specific. If the coefficient of the variable that is squared is positive, so it opens upward. If A is positive, okay, so the parabola will open upward if A is positive. So it will look like this. Okay? If, let's go back to yellow. If it is negative, if A is negative, it will open downward. So if A is negative, it will open downward. All right, to graph quadratic functions, you don't have to write all this down. This is in your text, okay, in your text pages. But I do want you to write this part down that I'm going to highlight right now. To graph a quadratic function, you're going to make a table of values, plot the ordered pairs, and connect the points with a smooth curve. If you look at the first example, we have y is equal to x squared. What variable is in front? What kind of number is in front of the x? Is that a positive or a negative? In front of the x. Good. So, right there is a positive 1. Okay? So, that's a positive 1 in front of that squared term. My graph is going to go open up or down. Which one? It's going to open up, just like you see right here. Right? If you look at the second example, the y is equal to negative x squared plus 4. Positive or negative in front of the squared term? That's a negative in front of the squared term, right? So since it's a negative in front of the squared term, the graph opens downward. Is everybody clear? All right, very good. So let's take a look at this one. We want to graph y is equal to 6x squared. So first step, make a function table. The rule, the function rule, 6x squared, goes right here in the middle. So this is going to be 6x squared. Now, I need to choose some values to put into my equation. Now remember, if you square a number, it gets big really fast. Okay? So we're going to start with 0 and 1. And then if I need to, I'll put 2 in there. Okay? So, let's start with negative 1, 0, and 1. Negative 1, 0, and 1. So we just substitute in and simplify, just like we've always been doing. So, we've got 6 times negative 1 squared. What do I do first? You square it. Very good, because PEMDAS says exponents first, right? So, negative 1 squared, that's negative 1 times negative 1 is?
1.
Positive 1. So, negative 1 squared is positive 1 times 6 is? 6. Very good. We put a 0 in there. 6 times 0, of course, is? 0. We put a 1 in there. 6 times, oh, we put the square. And you got to square that, right? So, 1 squared is 1 times 6 is 6. See that? Now, let's see what happens if I put 2 or negative 2 in there, okay? So, 6 times 2 squared. What's 2 squared? 4. What's 4 times 6? 24, right? That is going to go way off my paper, right? Is everybody clear with that? That's why sometimes it's okay to just have negative 1, 0, and 1, okay? Same thing if I put negative 2 in there. negative 2 squared also is positive 4, and then positive 4 times 6 is also 24. What do you notice about these numbers? If I have a positive, if I have a, for my x values, if I have a positive, the negative of the same number gives me what? The same answer, right? That is where you're going to get a symmetrical picture, okay? So now let's graph. All right, so we have negative 1, comma 6. So negative 1, comma 1, 2, 3, 4, 5, 6. And then we have 0, comma 0, right there. And of course we have 1, comma 6. And like I told you before, if I went to 2 or negative 2, the graphs would be way up there, right? So we're just going to leave that off. So the next step, after we plotted our and graphed our ordered pairs, is to now connect the dots with a smooth curve. Okay? So now you can see that I have to put arrows on there because the graph will go on forever in that direction. Okay? So please make sure when you are drawing your quadratic, the graph of your quadratic function, you put arrows on the end. All right. Now, sometimes when we are looking at graphs or creating graphs from our function, sometimes, remember, you can't put negatives in. Remember we had some situations like that? Okay? Here, this says the function d is equal to 4t squared represents the distance d in feet that a race car will travel over t seconds with a constant acceleration of 8 feet per second. So there's the function that they have. Okay, so we're graphing time and distance, right? Thinking about time and distance, can you have either negatives of those? You cannot have a negative time and you cannot have negative distance. So time cannot be negative. So we only use positive values of t. On this one, the same kind of problem here. They said represent the distance d in miles you can see from the height of h feet. Okay? Can you have h and negative height? Can you have negative distance? No. So distance cannot be negative, so you're only going to use positive values for d. So let's take a look at this example, and this is interpreting the quadratic function. The outdoor observation deck of the Space Needle in Seattle, Washington is 520 feet above ground level. We want to use the graph to estimate how far you can see from the observation deck. The important information that we have in this word problem here is that, where are we standing? We are standing on the observation deck, which is 520 feet above ground level. Okay? Now they want to see how far, we want to estimate how far we could see if we're standing on that deck. Okay? So, 520 feet. 520 feet. Here, if you're looking at the graph, there's 600, there's 400, so 500 is right in between there, right? So 500 is right in between, right there, right? But we don't want 500, we want 520. So let's see, 550 is right in between 500 and 600, right? So 520 is a little bit lower than right in the middle. Does that make sense? Right about there. Right. So from that point, you're going to go to your graph, okay? So you're going to draw a line from that point to your graph, right there, okay? Now from that point, let me put a point right here. From that point, you will draw a line down to the x-axis. So about right there. So, from 520 feet, about how far can we see? 30 what? Miles. From about 200 feet to 520 feet, we can see 30 miles out. Take.